A farmer has 200 meters of fencing to create a rectangular enclosure. What dimensions will maximize the area of the enclosure? So this is the idea of optimization problems, which is 511 here. The idea behind an optimization problem is you are trying to take an equation, take the derivative of it, giving you critical points, and critical points give you a local maximum or a local minimum. So let's start out with what we know. We have a rectangular fenced-in area, so this is me doing the best I can drawing a rectangle, and I did a decent job here. We'll call you length and width. And we know that we have 200 meters to work with. So using the information we learned from elementary school, 2 times length plus 2 times width is equal to 200. That's my perimeter formula. Now, what I'm also trying to do is maximize the area. So another equation that I could use is A equals length times width. Now, my job is to maximize this, which means I want to take the derivative of that. Right now, I don't want to because there's 2 different variables. Oh, but since I have this equation, I could solve this equation for like L or W, plug it into that guy, and I only have 1 variable to deal with. So let's do that. Let's solve it for W. Let's subtract 2L, cross U out. 2W equals 200 minus 2L, like so. Divide everything by 2, divide everything by 2, divide everything by 2, cross U out. W equals 100 minus L. So now what I can do is I could take that equation and that information and create a brand new equation. Even though I put the arrows there, I'm going to put it way over here. A is going to equal instead of, well, I'm going to keep LL, and instead of W, I have 100 minus L. Distributive property tells me that A is going to equal 100L minus L squared. Now let's take the derivative of that. A prime is going to equal 100 minus 2L. In order to find the critical points, you set it equal to 0. So 100 minus 2L. Let's add 2L to both sides. So let's move this up here. 2L equals 100. And my one and only critical point is going to happen at 50, which means 50 exists at a maximum or minimum. And in this case, it's going to be a maximum because the numbers make it work that way. Now, if the length is 50, I need to find the width. Up here, it says that the width is 100 minus L. So the width is going to be 100 minus 50. So the width is 50. My job is to maximize the area. Area is length times width. So area in this case is 50 times 50, which is 2,500. So it's going to be A. Now, a fun fact, if you're given a rectangle and all 4 sides to make fencing out of, your maximized area is always going to be a square. Always, always, always. Now, later you'll see me do a problem where I have the fencing holding up against a barn, where I only care about 3 sides. That's not going to be the same. But in this case, we get a square, and that makes sense.